Welcome viewers to On Class TV. I am myself Alewi Tosin. This is the fourth segment of the three-dimensional shapes, also referred to as solid shapes. We've discussed about cube, we discussed about cylinder, we discussed about cuboid. So this time around we're taking cone as an example of what a solid shape. This is the diagram of the cone here. We have this as the perpendicular height, this is the slant height, and we have this as what? The base radius of the circle. What is the base radius of the circle? A cone is formed, the curved surface area of a cone is formed from folding the area of a sector. The curved surface area of a cone is gotten from what? From folding what? The area of a sector. Now, while getting that from the area of a sector, we need to also take note that what? That the length of arc of a cone, which this is the formula, gives the what? The base circumference of the cone. The length of arc of a sector gives the base circumference of the cone. Length of arc of a sector gives the base circumference of the cone. So we can say that theta over 360 times 2 pi L. This case now we use pi L. Why? Because when we fold the sector, our R here becomes our slant height. R becomes slant height when we fold what? The sector. So with this now, making our R sort of the formula, you can say because to multiply here, we have theta 2 pi R. Theta 2 pi R is equal to 360 bracket 2 pi R. Now we are trying to see, let's divide through by 2 pi. Divide through by 2 pi. So this cancels this, our pi cancels pi. Also goes with this, so we say theta L, which is the angle of sector. At time we say the angle of sector is equal to what? 360 R. Now, questions will tell us to find the base radius of a cone. The base radius of a cone. So we are told to find the base radius of a cone. We are saying that what? Our R equal to theta over 360. Where our L, the L here now is what is slant height of the cone. Slant height of the cone. So this is what the base radius of the cone. So the slant height of the cone is equivalent to what? To the radius of a sector. Radius of a sector. So that will be the first formula we'll be deriving. That it's very useful in our consequent questions. Okay, now let's take the cone. Because this area is a round part of the what? Of the cone. Now, we said it can be gotten by what? By folding the area of the sector. Cos of the cone can be gotten by what? Folding the area of the sector. The area of the sector is given at theta over 360 pi L square. That's the area of the sector. It's about 360 pi L square. So with this now, we can say that our CSA is what? Is theta over 360 times pi L square. Now, if you recall that we said our radius, that's the base radius of a cone, is given as what? As theta L over 360. So from this now, we make theta over 360 formula now. Divide by L. L cancels. Okay. L cancels L. So we can say that what? Our theta over 360 is equal to R over L. So we solve for this. Let's call this equation 1. You solve for this. For theta over 360 equal to R over L in theta over 360 by RL square. So our theta over 360 represent this. So we have our CSA of a cone will be equal to what? Theta. Instead of writing theta over 360, now we write R over L times pi L square. L cancel 1L. So we see that the CSA of a cone is equals to pi RL. Making the second formula that we need to what? Put in our brain for this topic. Now, getting our cross surface area as pi RL, we can also say that alternatively that we consider this triangle. We're having a right angle triangle there, of which this is our hypotenuse, this is the adjacent, and let's take it as what? Opposite. So we can say, using Pythagoras theorem now, we can say that our L square is equals to H square plus R square, which means that we say that you root both sides now. Root cancel square, you say L equals to root of what? H square plus R square. Now let's call this equation 2. If you solve for this, if you solve for L equal to L root of H square plus R square in CSA, the CSA now. Our CSA we say is equals to pi RL. So it means that what our L now will be, so we say our cross surface area will be equal to pi R in bracket square root of H square plus R square. So that's also another formula you can use to find out our cross surface area of the cone. That's considering